So the next study we did, and actually one of the IU students, she was here last summer, and he did most of this study, where he studied the different configurations of I/O on these virtual machines. So most of these virtual machines come with a local disk, which is not a permanent storage. So every time the VM goes away, you lose what's on there unless you've saved it beforehand. Elastic block store is a device-level storage method where you can actually load it, and it's use it to save persistent data. And the persistent data is it's useful, but the only problem is you can only sort of mount this on a single VM at a time on Amazon, and most of the open source versions of Amazon, like Eucalyptus and OpenStack, that are available. So what you have here is essentially you're seeing the write and read performance here, and what you're seeing on the y-axis is throughput in megabits per second, and you see that the performance here is significantly lower than sort of what the performance we see on our parallel file systems. Not unexpected, but it's something we had to note mostly because that's what our users are used to. They use GPFS here at NERSC, and 2,500 to 3,000 megabits per second is sort of what they're used to, whereas you see significantly lower I/O here. But this is interesting because a lot of time people talk about clouds as being good for data-intensive and I/O related stuff, but the performance you get doesn't always mirror that. We have a more detailed study of this in the paper that's listed in the bottom of that slide, but we had a few surprises because it doesn't seem there was a lot of variability that we were seeing on Amazon especially, and some of them surprised us because we were able to get better write bandwidth on the Amazon small instances than the large instances, where we sort of expected that the small instances were more shared, so on a node, so that we would see a little lower. But there's enough variability that it's really hard to say what you could expect. The large instances, EBS typically did, especially the CC instances, EBS did really well because it had the 10 gig bandwidth that was available to it, and the EBS, the file servers are different from the machines that are hosting the VMs here. So I sort of talked a lot about, up until this point, about what's bad about cloud computing for scientific applications. And a lot of people then look at it and said, so is cloud not for science apps? No, that's not true. I think it's just we were looking at a range of different science apps here, and some of our mid-range to high concurrency workloads, or tightly coupled workloads, won't perform as well because of the communication overheads in a cloud environment. But there are lots of other applications that are high throughput applications like BLAST, which is a bioinformatics application. And here's a graph that, again, a study we did in 2009, where we compared it on a set of different systems, and including EC2 and Windows Azure. And essentially, the performance is comparable. There's no loss in performance. It does very little I/O relatively. There is a little bit of I/O, but little I/O, and it's able to do pretty well in cloud environments. So I just wanted to put this up as sort of some applications that do well in the cloud environment. So after the sort of performance study, while the performance study was going on, we also had to ask ourselves sort of how difficult this whole environment is to use. And our conclusion really was that clouds do require a significant programming and system administration support. It's not an out-of-box solution for science as it might be for the web workloads. What we realized was we had a Magellan support list, and a number of the questions that we would have to address and answer were related to system administration, right? Because while clouds give you this control where you can create your own OS, you can manage your own software, but then comes the responsibility of managing all that. And a lot of our users typically don't have to handle complex software installs or managing the network and the disk and everything on their VMs. So we got a lot of questions related to sysadministration. So the question we really ask ourselves is, moving to a cloud environment means it puts an immense burden on some of our users to learn system administration skills. All that needs to be provided as a support model that they could reach out to and get help to do some of these things. So in terms of this graph here shows STAR, which is probably one of our poster childs in terms of their use of cloud computing, both on Argonne and NERSC resources. And what they did was they did a real-time analysis of data that was coming from Brookhaven National Lab. And it was great for them because this was the first time they were able to analyze the data in real time to a high degree, whereas this would have taken, I think they estimated this as a year or something close to that of analysis after the experiment was done. So this is great for them in terms of having real-time access to that. They ran into a number of problems here, what I was referring to earlier in terms of just getting their software up and running on the VMs, right? So they've been running on the NERSC systems for a while. So we had a number of support staff at NERSC who could help them out. But essentially what we ended up doing was we took an existing OS image from the NERSC system and then just connected to, just put them on the VM. So they started out with 20 VMs at NERSC, and then they expanded to Argonne. They ran for a few months across both sites, and it was pretty good experience for them. And STAR is definitely one of the leading users of cloud computing that we've seen, at least. So the challenges, to summarize, we had an image creation and management challenges. There's also a workflow and data management problem because a lot of these users were used to sort of submitting the jobs into a batch queue and they were done. They sort of now had to figure out how do you get the data from Brookhaven to the VMs. We ran into some issues where we were essentially choking a little bit because the data transfer was overwhelming the VMs. So we had to sort of come up with some strategies to manage the data transfer and offset some of it by going to the physical machines and then moving it to the virtual machines. And they had to also manage their job distribution, sort of how do you tie these set of virtual machines that's available to them to do something. We built a bunch of scripts and images that our users could use to help them out, but the learning curve was still significant. And there was issues with performance and reliability that these applications were not designed for, just based on where they run today, that they needed to handle in their middleware or software layers.